Okay, so today I'm going to talk to you about Rotovap, which is an abbreviation for rotary evaporation, which is regarded by many people as the best way to separate compounds from a mixture. It's usually used to remove low boiling compounds from a solute, and so it's important, just as with distillation, that there is that separation in boiling point in order to properly separate the solution. So in order to understand how it works, it's first important to understand a bit about the apparatus. So the Rotovap uses a vacuum to lower the pressure within the system, and so that's what you see right here, denoted by number 1. And then number 2 on the screen is just some control knobs to kind of regulate the different settings. Number 3 is a water bath, which is used to heat the solution. Number 4, this round flask right here is where the solution goes, and then towards the top of that is a bump guard, which prevents the contents of the flask from being drawn into the condenser should bumping occur during the boiling process. Up here, number 5 is what they call the cold finger. Oftentimes it has dry ice around it, but it just does the same thing as a condenser in a simple distillation setup. And then number 6 is just a valve that releases the pressure from the vacuum once the experiment's over. So how it works, essentially, it allows for the removal of a solvent from a solute. And both of these are in a solution. The solvent is volatile, and so it vaporizes more quickly than the solute, which is non-volatile. In many ways, it's very similar to distillation. Even you can see by the apparatus that there are many similarities. Rotovap is able to separate the volatile from the non-volatile solution in 3 main steps. It increases the rate of evaporation by reducing the pressure through the vacuum, and when the pressure is reduced, the boiling point is also reduced. It also rotates the sample, and as it's rotating the solution, more surface area is exposed, which allows it to evaporate faster, and then it's also heated, as you saw in the previous slide. As the rate of evaporation increases, the volatile solution begins to vaporize and move up the flask towards the ice finger. Once the vapor reaches the ice finger, it is cooled very quickly, causing it to recondense as a liquid, just as we saw in our distillation experiment. The recondensed liquid is then collected into a receiving flask, and this is done until all of the liquid sample is gone from the original flask, or until the desired amount of solvent is obtained. So to perform this technique, it's pretty similar to our distillation. You're going to assemble the apparatus as shown in the first slide. You are going to turn on the vacuum to kind of prep the system, and then also begin heating the solution in the flask. Like I said earlier, it's important to pick a solution that has a solute and a solvent with different boiling points, so you're able to properly separate it. You're going to allow the solution to heat and for the vapor to begin to form. As the solution begins to vaporize, it should be visible around the ice finger. You may begin to start seeing little little condensation or drops of liquid. As the vapor surrounds the ice finger, the vapors will recondense and be caught into the receiving flask. And you're just going to continue heating the solution until the solvent and solute have been separated or the desired amount of solvent have been obtained. These are just the sources I used to make this PowerPoint and this presentation. Thank you for listening.